Hello students, I am Smita Patnaik from Electronics and Telecommunication Department. So today we discuss about digital electronics. So first of all we discuss introduction to digital electronics. Okay, so what is digital electronics? Digital electronics is a field of electronics which deals with the digital signals. For example, your personal computers and smartphones and our day-to-day life, many digital equipments which are used in digital electronics. Then comes to analog electronics, means a field of electronics which deals with the analog signal. For example, your amplifiers and different wave shaping circuits are all belongs to this analog signal. So here we study about analog versus digital signal. So what is analog signal then? A signal whose amplitude can take any value in the given range is called analog signal. Analog signal is mainly classified into two types. Okay, first one is your voice. First one is your analog continuous signal and analog discontinuous signal with respect to time. This signal which is continuous in time and continuous in value is called analog signal. And the analog signals are like our voice signals, natural voice signals, for example, temperature and pressure. These all are related to analog signals. Okay, students, I hope you understand. And here this analog signal is two types, analog continuous as well as analog discontinuous. Okay, so the system which is varies analog signals is called your analog systems. Next comes to our digital signal. Okay, so what is digital signal then? A signal whose amplitude can take any finite number of value is called digital signal. The digital signals are continuous and discontinuous. So next comes to digital logic levels. The digital logic levels are mainly two types. High is represented by high logic high and low is represented by logic low. The input and output of these digital circuits are often represented by binary numbers. Okay. Then this logic high is represented by 1 and this logic 0 is represented by logic low. Okay. So this can be represented in terms of voltage level. In terms of high voltage level means high voltage is represented by 5 volt and low voltage is represented by 0 volt. Okay. If the voltage level is between 2 to 5 volt, then it can be considered as high voltage level. Okay. If the voltage level is within a certain level, if the voltage is for example 0 volt to 0.8 volt, it can be considered as 0 voltage level. So this is the advantages of digital system. If the noise and interference gets superimposed of that particular signal, then also as far as the signal level is in a certain range and it can be identified as logic 1 and logic 0. So these are the some basic advantages of digital systems. First one is easy to store and replicate and process. Okay. Second one is high accuracy and more reliable as compared to analog systems. And third one is it is also possible to fabricate in the larger density, which are not possible in case of analog systems, and easily scalable. So these are the basic advantages of digital systems over analog systems. But most of the natural voice signals or natural occurring things are comes under analog signal. Okay. So we must use analog to digital converter to convert the analog signal into a digital one. So digital one is represented by 0 and 1 bit. So we can convert here also, in some cases we can convert the digital signals into analog one by using DAC, means digital to analog converter. Okay. So here we use some ADC and DAC for conversion. Next we are looking forward to digital circuits. Okay, so digital circuits are also known as here switching circuits, and this can be represented by high value as well as low value. Okay students, so do you understand? And it also perform logic operations. That's why it is also known as logic circuits. Okay, so example, using this digital circuits, it is possible to design the circuit which will turn on the fan when it is a daytime, when its temperature is 25 degree. Okay, next comes to digital circuits, logic gates. So logic gates are the basic building blocks of digital circuits. Here some gates are there. These three gates, AND gate, NOT gate and OR gate, are called basic gates. And rather than that, two more gates are there, that is called universal gates, which are NAND gate and NOR gate. Okay. So apart from that, more two gates, that is exclusive gates, XOR gate and XNOR gate. Next come to digital circuits. So here by using this we can implement different types of logical operations. Okay, these logical operations are by using these gates we can perform logical operations which is represented by our Boolean algebra. Okay, by using these gates it is possible to perform logic operations, and any logic operations is called an Boolean algebra. This Boolean algebra is used to reduce the Boolean expressions. Next we come forward to, there are two types of circuits, digital circuits. First one is your combinational circuit and second is your sequential circuit. Okay, this combinational circuits are one where its output depends upon present input, while in case of sequential circuits output depends upon the present input and past output. Okay, so here digital circuits, some logic operations are like arithmetic operation and comparison, encoding and decoding, multiplexing and demultiplexing, storing and counting. Okay, in the next videos we will discuss about these basics of digital circuits one after another. First one is your what I told, binary numbers. By using binary numbers we can represent digital electronics, and by using this logic gates we also represent the logic operations. Secondly, binary numbers, then comes to logic gates. Then these logic gates will help to solve the logic operations, that is called Boolean algebra. And two more circuits, combinational circuit and sequential circuits, and this finally logic families. I hope you understood well. Thank you.